Guys, I'm still here because I don't want you to think physics is over. Physics is more than, I want you to think physics is more than the exam you will take on June 24th. So I'm here to go over assignment 85. What is that? The sound characteristic. More importantly, the Einstein computation on Monday gonna be based on assignment 85, and that's what I'm gonna go over right now. And also the Einstein final. Someone will take the Einstein home on this Friday, right? Einstein final also going to be based on this. So let's dive in. In this tutorial, you're going to learn everything you need to know about sound, right? So for example, the velocity of the sound in the solid is higher than velocity of the sound in the air, and also you want to see why the sound bends from warm air to the cold air, right? In the cold morning, if you shout like this, it's going to go like this and going to come back like that. Why is that? And also we're going to see how do we know everything about the earth interior, right? Inner core, outer core, mental, and the class, because we understand sound. So we're going to go over reflection, refraction, uh, diffraction, Doppler effect, interference, standing wave, and along the way we probably going to solve some math problem to prove some of the theorem. Let's dive in the first thing, the sound wave. So what is sound wave? So let's start with the wave. So let's say psi x comma t is equal to, I don't know, 0.4 sine, let's say x minus 2 pi t, right? Okay. And then psi 1, psi 2 is x comma t is equal to 0.4 sine x minus 2 pi t plus p, right? phi. All right, so if I ask you to do psi 1 plus psi 2, what are you going to do? You want to write a, right? A sine x, right? Plus b, right? Sine x plus p, right? And then you can do this. You can say a plus b is r, resultant, sine, you can say x plus delta, right? Okay, so what is delta? What is r? So what is r? R is square root of a square plus b square plus 2ab cosine theta. And I'll give you the theta. Let's say theta is pi over 8. Okay, that's the phase shift. Right, so R is, A is 0.4 square plus B is 0.8 square. So this, let's say this is make 0.8 just to make some difference so you don't, yeah, there is no confusion. All right, plus 2.4.8 cosine pi over 8. All right, so this is 1.17. I don't know, is that so? Yeah, probably. So psi 1 plus psi 2 is equal to, R is 1.17 sine. So what is delta? So the delta is, you have sine B over sine A over sine B, right? So we have delta. Delta is tangent delta. Delta is A sine P, B sine P, B cosine P, A plus. So what is our A? A is 0.4. What is our B? B is 0.8. What is our P? Is pi over 8, right? So I have B is 0.8, sine pi over 8 is 0.4, right? A is 0.4 plus B is 0.8, cosine pi over 8 is 0.9. All right, so what I have, delta is equal to inverse tangent 0.8, 0.4, 4 plus 0.8 times 0.9, and that is 0.26. So now we're going to come over here, we're going to write our equations. Pi psi 1 plus psi 2 is equal to 1.17 sine x. What is x? X is x minus 2 pi. So x minus 2 pi plus 0.26. Okay, so this is our final equations. Two more things you're going to try to understand, and then you're going to move to wave velocity and especially sound velocity. Okay, so what are you going to understand? All right, I'm going to say psi is equal to I don't know, psi x comma t is equal to 0.4 sine, I don't know, let's say 10 pi t minus 50 pi. No, 10 pi x minus 50 pi t. Now, if I ask you, how long does it take for 3 cycle? What are you going to say? 3 cycle. All right, so to do 3 cycles, what are you going to do? You're going to first try to find the period. So omega is 2 pi over t, right? So 2 pi, so t is equal to 2 pi over omega is 50 pi. So t is equal to 1 over 25, right? So now what is then time for 3 cycles? So 3 times t. So 3 times 1 over 25. So t is equal to 3 over 25. If I ask you for n cycle, how long does it take for n cycles? You're going to say n, t is equal to nt, right? And t is the period and t is the time it takes. Right? 3 cycle would be like this: 1 cycle, 2 cycle, 3 cycle. This is 3 cycle. 3 cycle, how long does it take? 3 over 25 seconds, right? n times 1 over 25. Okay, all right. So n over 25. If I ask you to find the velocity, how are you going to find the velocity? By velocity is omega over wave number. So velocity is omega. What is omega? Omega is 50 pi and wave number is 10 pi. Velocity is 5 meters per second. Of course, you can find the velocity traditional way. How is the traditional way? All right, so this is the wave number is, what is it? 2 pi over lambda. So lambda is 2 pi over wavelength. So lambda is 2 pi over 10 pi, right? So lambda is 1 over 5, right? The frequency omega is okay, 2 pi f, right? So f is 2 pi. So f is 50 pi over 2 pi. So f is 25. So velocity is lambda times frequency. So velocity is lambda is 1 over 5, frequency 25. So 5 goes to 25, 5 meters per second. So both way you get the same answer. One is faster, one is not so fast. I'm going to show you why the sound, when I say something, for example, if I say, what you did not hear, although I created sound inside my mouth, but you did not hear. Why? Because the sound created by mouth did not come out with the threshold frequency, so that it leaves my mouth but never arrive your ear. Why is that? Because the sound coming from my mouth has to assault the ear, so the ear takes the information from my mouth to your ear. That's why you're going to see that the speed of sound is greater in the solid. Why? Because solid, the atoms, right, the molecules are very close together than the water, and then of course the air. Okay, let's take a look what I mean. We're going to say solid, liquid, and then gas. All right, solid, liquid, and gas. Solid velocity is you have a bulk module over the bulk module over density, and this one velocity of sound, of course, bulk module over density. So what is bulk module? Try to understand bulk module. See, if I want to deform, all right? If I want to deform this one will resist the deform, right? I don't know, I don't have anything to deform. Let's see what I can deform. I can deform this one, right? If I do deform this one, this will resist, okay? Well, not much. But I cannot deform this one just like I did deform the paper, because this one resistance would be greater. So that's the bulk module. So the bulk module is 200 times 10 raised to 9 Pascal. And the density of the solid is 8,000 kilogram per cubic meter. So velocity of the sound in the solid is 5,000 meter per second. Now let's see in the liquid. The bulk module is, of course, 2 times 10 raised to 9 Pascal, right? You want to deform the water will resist the deform, right? Water will say no to the deformation, and this is 1,000, right? So velocity is 1,500 meter per second. Now, this one bulk module is bulk module and the density. So the bulk module of gas is 10 raised to 5 Pascal, and then this is 1.3, right? So this is about 300 meter per second, but this is not accurate, right? Why? Because this is elastic bulk module, and elastic bulk module, the air doesn't really have much to say when it comes for you to deform it, right? Air doesn't resist the deformation as much as the water or the solid. So we're gonna apply a different formula. Gas. Now, right now here in this room, made of course, oxygen, and nitrogen, and argon. So you have nitrogen gas, oxygen gas, and argon. Nitrogen gas, nitrogen is 7. So you have, so nitrogen is 7, 14, and oxygen is, I don't know, 8, 16, and argon is 18. All right, so now we're gonna do, so 2 of them, so 28, this is 78%, this is 78%, this is, I believe, 22%. So 78 plus 22, no, this should be then 21%. So 78, 21, so 9, okay, so this is 1%. This is 1%. So you have 78, so you have 28.78 plus 32.21 plus 40, because this is this is one of the isotope is 22, so this is 40. Okay, so this is, although this is 18, this is 40, one of the isotope is 22. Okay, so this is 40, 40.01. Okay, great. So what is the velocity formula? Velocity is gas constant, all right? So so the gas constant, this is temperature, and this is molar mass. So the molar mass is, okay, so we're gonna get this one, molar mass is 0.029. So this is 1.4, this is R is 8.314, and T is 27, okay, 0 degrees Celsius. This is 273 Kelvin. 273, and the molar mass is 0.029, and so velocity is 330 meter per second plus 0.6 t. What does that mean? If temperature go up, of course the velocity go up. Okay, now you see that this one velocity is greater because the molecules are very close to each other. This one, molecules are not that close to each other. This one, molecules are very far from each other. That's the reason velocity of the sound is more and less the way you see it. Now, let's go reflection. So what is the reflection? So reflection is, all right, reflection. Sound reflection is theta initial is equal to theta final, okay? One of the consequence of reflection is echo. All right, now let's see let's say, yeah. So, uh, so sonar signal. All right, let's say this is ocean. This is ocean, and this is a boat. You send a sonar signal, right? And it takes, you send a sonar signal. This is incident ray, and this is reflected ray. All right. It takes 2.4 seconds for the sonar signal to return. What would be the depth of the ocean? So what are you going to do? You're going to do two ways to find the depth. One is this way. Velocity is 2d over t. Why 2d? Of course, it takes, this is incident, this is reflected. So 2d. So the captain get it back 2.4. So 2d is equal to vt. So d is equal to vt over 2. Now this one we're gonna just vt. If we do this one, b is 340. Okay, all right. This is 1500 meter per second. Why is that? Because we just proved that few seconds ago. The speed of sound moves 1500 meter per second in the water. So 1500, 2.4 over 2. So 1800. So d is equal to 1500, 2.4, so 1.2. So this is 1800 meters. Okay, both way you get the same answer, but understand the difference. Why we use 2d over t instead of just d over t. Okay, another problem. Let's say Mr. Bari is in the middle of something, in the middle of I don't know, 500 meter wall. This is wall 1, wall 2, right? And then he claps. What does he do? He claps. So if he does claps, so it's go incident ray and then reflected ray. It takes 1.5 seconds for him to hear the echo, right? What is the distance? So again, we're gonna do distance two different way. D is equal to, right, Vt over 2, and d is equal to Vt. All right, so d is equal to V. This is here. We're gonna say 340 meter per second, right? Temperature is not 0 degrees Celsius. It's like about 15 degrees Celsius, right? Okay, so 15 times 6, right? 15 times 6. 15 times 0.69. Okay, so that's about 340. Yeah. So 15 degrees Celsius. Okay. So B is 340 and time is 1.5 divided by 2. So the distance is 255, right? And D is V. V is 340 and T is of course half. 1.5 1.5 divided by 1.5 divided by 2. So this is gonna give you 255. So from here to here is 255 meter, right? Now we want to find also how long does it take for him to hear this, right? Okay, so now again we're going to do two way. So first part we're going to find t and t. So what is t? T is all right. So we're going to draw bt is 2d. So t is 2d over v, and t is d over v. So t is 2d. If this is 255, this must be 144, 145, 245, 245, 245, 245. And velocity is 240, right? So t is 1.44, 1.4. I don't know. Let me see. 2 times 245 divided by 340, 1.4. So t is equal to d, which is 245, velocity is 340, and of course this one not gonna give you 1.4. 245 divided by 340, and this one gonna give you 0.7. So you understand the difference. This one is echo, right? Echo takes 1.4 seconds, right? And this is not echo, right? To make it echo, you multiply it by 2. Understand always the difference. If you don't, then do. Okay. All right. So that's about it. Then the next thing we're gonna do is refraction. So refraction. refraction. So what is refraction? Refraction is the bending of sound wave. Why does the sound wave bends? Because when you change the medium. All right, let's consider water and air. Let's put a normal. Let's consider a fish. All right, this is a fish. What does fish do? Make a sound with respect to normal, of course, 30 degree, right? Where do you have to be? At the x-axis on the ground or on the tree? So to hear the fish, let's find it out. Okay, now to do that, we're going to do sine theta 1, velocity 1 is equal to sine theta 2, velocity 2. Sine theta 1 is sine 30, velocity 1 is 1500. Why is that? Because this is water, 1500. And this is 15 degrees Celsius. Okay, great. Is equal to sine theta 2 is over 340. All right, so theta 2 is equal to 6 degrees. So this one is 6 degrees. Yeah, so it seems like you're bending toward the normal, right? Okay, now let's see the application. Application of refraction. Application, there is a great application of refraction. Like, let's say windy, cold day, all right? So this is morning, like 6 a.m. So this is cold and this is hot. All right, so let's put some layer. 100, 1, 2, 3, 4. This is hot. So this is, let's say this is 500. Let's say 600, 500 meter per second, meter per second. What is speed of sound? 400 meter per second, and 300 meter per second. So a man shout this direction, right? A man shout this direction. Yeah, make a sound at some degree angle, right? So it's moved, but it always want to come back to hot to cold. So how is going to come back from hot to cold? So this is going to go, and this is going to, this always going to come, all right? So let's say with respect to the normal, this band is 30 degree. So it's going to be less than 30 degree. This one going to be what? This one going to be, let's say, I don't know, 24. And this one going to be what? 18. Okay, and this one going to be what? 12. And so on. So as you see, it's bending. It's bending. How did it get 24? Well, the math is easy. Sine theta 1 over V1 is equal to sine theta 2 over V2. Sine theta 1 is sine 30 over 600 is equal to sine 30 sine theta 2 over 500. And you're going to see theta 2 is less than 30. I don't know whether it's 24, 25. It really doesn't really matter. Now let's see the other way. Other way, you have the 9 p.m. Okay, you have now hot, cold. So this is 600, this is 500, this is 400 meter per second, of course, meter per second, of course, meter per second, of course. This is 300 meter per second. Now a man also shout the same way. Okay, a man shout. If a man shout, okay, like this, so with respect to the normal, right? This is 30 degree. So what we're gonna do? We're gonna find this one. So this one, if this is hot, this is cold, right? So this one bending from hot to cold. Now this one gonna bend from where? From this one gonna go this direction. This one not gonna see. This one not gonna go into x direction like that. It's not gonna go to the x direction. It's gonna go to the y direction. It's gonna bend like this. It's gonna bend like this. It's gonna move to the cold. So let's see what this one gonna be. This one gonna be, I don't know, 24, and then this one gonna be, I don't know, let's say I don't know, let's make it up, 18, and then this one gonna be 12 and something. So it's moving from hot to cold, but not like this, not like this. All right, and how do I do that? Okay, let's say sine theta 1 over V1 is equal to sine theta 2 over V2. Sine theta 1 is 30, sine 30, and this is hot. is equal to sine 32. That's what we want to find. And this is B2 is cold. Not cold, but this is 500 sine 30 is equal to 600 sine theta 2, right? Let's really find it out. Okay. I have sine, inverse sine, which is over here 250 divided by 600. And that is 24.6, right? 24.6. So you're going to see it's not going to bend this direction. It's going to bend this. It's finding cold. It's finding cold for this reason. And another application for refraction, I don't know where is the eraser, but the natural eraser is my hand. Okay, another application is the earth interior. So this is the earth, right? So this is our inner core. 50 kilometer. This is about 2,500 kilometer. This is about 5,000 kilometer. This is about 6,000 kilometer. So if you add them up, 2,500 and then 5,000 and then 6,000 and then you see 0, 0, 5 and then 7 and then 13. Okay, so this is your diameter, right? Okay, this is your diameter. So if you find the radius, and that would be let's say 13,000. So 6.5000, right? Okay, and then you put 3 more 0 to make it meter. So it's 6.5 times 10 raised to 1, 2, 3, 4, 5, 6. Okay, now this is one less 0. So this is kilometer. So this is meter. So 6.5 times 1, 2, 3, 4, 5, 6 meters. So this is pretty much the real radius is 6.4 times 10 raised to 6 meters. So more or less, my estimate is good. That's how you can do estimate. Now let's do temperature. So this is the depth. Okay, temperature is this is 1,000 Celsius. This is 2,000 Celsius. This is 4,000 Celsius. And this is 6,000 Celsius. Believe it or not, we have sun in the center of our Earth, planet Earth. The sun surface temperature is 6,000 Celsius. The inner core is about 6,000, more or less 6,000. That's pretty awesome. All right, so that's temperature. What else? Velocity. This is 7 kilometer per second, and this is 9 kilometer per second. This is 10 kilometer per second, and this is 11 kilometer per second. As you see that the velocity increases as the temperature increases, loosely, more or less. Now, finally, you're going to see the density. So density is 3 gram per cubic centimeter, right? 3 gram per cubic centimeter, 6, and then 9, and then 12. Okay, so then the velocity increases as density increases. This can be P waves and S waves. This is P waves and S waves. This is only P waves. This is because this is liquid. The S waves cannot move through the liquid. And this is, since S wave cannot pass through this one, this is only P waves. All right, now let's see how scientists use refraction. So to understand how waves refract. So the P waves, it starts, let's say the P waves start, this is crossed, and this is mental. This is mental. Okay, so let's say the P waves started over here. This is our normal. P waves moves 30 degrees, right, because of earthquake. All right, and the velocity over here in the crust is 7,000 meter per second. The velocity over here is 9,000 meter per second, right? Now we're going to see whether this sound wave Move to the normal or move away from the normal. Okay, so sine theta 1 is equal to velocity 1, sine theta 2 is equal to velocity over velocity 2. So sine theta is sine 30, velocity 1, which is 7,000, is equal to sine 32. Okay, that's what we are trying to find. Velocity 2 is 7,000. So 7,000 sine 30 is equal to this is 7,000, this is 9,000. Okay, my 7 and 9 look same. This is 9, this is 9, 9. Okay, so 9, this is 9, sine 32, this is 9, this is 9, this is 32. Okay, so 9,000 sine 30 is equal to 7,000 sine 32. Okay, now what do we get? We get theta 2 is equal to sine inverse 9,000 sine 30 divided by 7,000. Let's see what we get. I think it's going to be moving away. So sine 9,000, 1, 2, 3, 9,000 sine 30 divided by 7,000. 42 degree, yeah, it's moving away. It's moving away 42 degree. All right, so that's how scientists use what we call refraction to understand something we cannot dig, and we cannot dig out. Not much. The maximum depth we accomplish digging 12 kilometers. Okay, that's a refraction. Now let's say diffraction. So diffraction is bending of sound wave to overcome the barriers. Diffraction. Diffraction. What is diffraction? Bending of sound wave to overcome barrier. All right. Now let's see a few examples. All right. So if I create a sound and deliver the sound with some frequency f, and there is a door, right? And the barrier is the door. Now let's say the door has a gap. The sound wave gonna find the gap to escape. All right. And the lambda is what? Velocity is lambda times frequency. So lambda is velocity over frequency. Okay. And then let's say relation. And let's say diffraction. Diffraction. So 1020 hertz. This is in hertz. This is in meter. This is also in meter. Okay. Scenario 1. Scenario 1. Scenario 2, 340. 15 degrees Celsius. Scenario 3, 170. Gap 1 meter. 1 meter, 1 meter. We keep the gap at the same. Lambda. So lambda is velocity is 340. 340 divided by 1020 is 0.33. 340 divided by 341. 340 divided by 172. So relation is what? Lambda is smaller. Lambda is smaller than the gap. Lambda is equal to gap. Lambda is bigger than gap. When lambda is, you have minimum diffraction. You have moderate. You have maximum diffraction. So let's draw it. Let's draw the scenario. The minimum diffraction, we're gonna try to draw it over here. So you have the gap, which is of course 1 meter. And this is moderate gap, which is of course also 1 meter. And this is gap, which is also 1 meter, right? So now I have the wavelength, which is 0.33. The wavelength is 0.33. So there will be no diffraction. The wavelength is 1. So the gap is 1. Gap is 1 meter. The gap is 1 meter. So wavelength is right 1 meter. So there would be some diffraction. So I'm going to draw those diffraction. So wavelength is now 2 meters. So then the diffraction would be maximum. So if someone is here, someone will be able to hear it. If someone is here, then someone will not be able to hear it. If someone is here, and someone will miss it. Okay. All the sound wave, because sound wave will not bend. Okay, so that's diffraction. Now let's go over Doppler effect. So what is a Doppler effect? Okay, so Doppler effect. So Doppler effect is the information received by source does not match with the information coming. Information received by the observer doesn't match with the information coming from the source. How can you ever write it? You write it by writing it. Velocity of sound plus minus velocity of observer. Velocity of sound plus minus velocity of source. And we're going to keep 15 degrees Celsius, right? Okay, now how can we draw this? Let's draw this. Let's put a truck driver, a very romantic truck driver. And what the truck driver does, he moves with 40 meters per second with this direction. And there are two person is on the road. One person is at location A, one person is at location B. Location A will experience high pitch. Why is that? Because there would be a change in the wavelength because he is assaulting the air. Because he is assaulting the air, and that creates what? That changes the lambda. Changing lambda, you change the frequency. Change the frequency, you change the pitch. One become high pitch, one become low pitch. Okay, so how you change the lambda? By assaulting the air, right? All right, so this is how it is happening. Okay, so what do you see? Over here, you see small lambda, so big frequency. Over here, you see big lambda, so small frequency. So the velocity remains same, right? Velocity remains same. Okay, good. All right, so now let's see. He honks with 800 hertz. Okay, now let's see, find what will A experience. A experience will be F, B plus minus B, B plus minus B. And A will experience 800, this is 340 plus 0, because A's velocity is 0. This is 340, this is plus. Why plus? Because of course it is moving toward A. A will experience high pitch. To have the high pitch, bottom has to be smaller. So 40, all right. So 800, this is 900. 900, okay, so 900, because 800, 340 divided by 300, so 900 hertz, more or less 900 hertz. So we're gonna call it high pitch. Now let's say B experience. FB is F, velocity plus minus V, velocity plus minus V. Of course, he gonna experience low pitch. So, the air would be assaulted less, this direction. So this is 800, this is velocity 340, this is 0, he is at rest. This is 340, this is plus. Why is that? Because the top has to be smaller, so this is 40, right? Okay, so this is FA. So FA is 800, 340 divided by 380, right? So this is FA is 340 divided by 380. 340 divided by 380 times 800, and that is 715, and we're going to call it low pitch. All right, so we went over I don't remember we went over everything or not, but let's write it down. Reflection. Yes, refraction. Yes, diffraction. Yes, Doppler effect. Yes, now we're gonna go over the superposition. So what is superposition? Superposition when two objects, right, when two waves are at the same location exactly at the same time, right? That's the superposition, okay? So what is the consequence of superposition? Interference. There are two types of interference, constructive and destructive. Constructive interference look like this. So this is wave one, right? This is wave one, okay? This is A, this is B. Let's say the amplitude is 2. So A plus B should be look like this, all right? A plus B. So this should be now 4. This is called constructive interference. Now destructive interference, all right, destructive interference, let's say this is A, this is B. And by the way, A and B has to come both the same direction. So this is B. This is going this way. This is going this way. So A plus B, and this is 2, and this is -2. So A plus B is 0. Amplitude is 0. Okay, now let's dive in a little bit math. So this is good, but not good enough. Okay. Let's see. Okay. Okay. I did in the beginning. I did go over the math. Let's do standing wave and then we do the math, some math. Standing wave. A standing wave, I'm going to show you the math of the interference. A standing wave is the interference. So what is the standing wave? A standing wave, okay, so you're going to use guitar. All right, a standing wave is an example of mechanical wave, and sound is a mechanical wave. So what is a standing wave? So let's say I have a guitar, right? So I have 1 cycle, 2 cycle, 3 cycle. Okay, so this is, I'm going to call incident ray, and this is going to be reflected ray. This is reflected ray. All right, by doing so, I created nodes. So what is the nodes? 1, 2, 3, 4, 5, 6, 7. So 7 destructive interference. And I created anti-node. Let's see, 1, 2, 3, 4, 5, 6, 6, and this is constructive interference. All right, let's say the length of the string is 12 meters, right? Let's say it takes 1 second. Okay, how many cycle over here? 1 cycle, 2 cycle, 3 cycles. So it takes 1 second. 3 cycle takes 1 second. All right, we're gonna try to find the equations for this universal equation for this. Let's see whether we can possibly get that. All right, this is called a standing wave, by the way. Okay, 3 cycles. We have length is 12. What do we have? We know that the psi 1 is going to be, okay, so amplitude, let's say 2. Amplitude is 2. So psi 1, okay, psi 1 is the psi 1 is this one. Psi 1 is A sine kx minus omega t. And psi 2 is A1, A2 sine kx plus omega t, because psi 2 is coming this way. Okay, this way is the negative, this way is the positive. We're going to put them together. You're going to say psi 1 plus psi 2. You're going to say A big A sine. You're going to say You're going to say sine a plus b over 2 cosine a minus b over 2. So psi 1 plus psi 2 is equal to a sine kx cosine omega t. Okay, so psi 1 plus psi 2 is 4 sine kx. What is our k? K is, I'm going to see, 6 loop, 1, 2, 3, 4, 5, 6, 6 loops. So one loop is lambda over 2. In a few seconds, we understand why one loop is lambda over 2, because it's first harmonic. And why we understand that this is first harmonic, second harmonic, third harmonic, fourth harmonic, fifth. Oh, by the way, this is sixth harmonic. So this is sixth harmonic. So the all right, sixth harmonic means 6 loops, right? Right. The one harmonic, the wavelength of first harmonic is lambda over 2. So this is 3 lambda is equal to 12 meter. What is 12 meter? The rope. Okay, so lambda is equal to 4 meter. Okay, so how that going to help us to find the equation? K is equal to what? 2 pi over lambda. So lambda is 4. So then K is equal to pi over 2. So K is equal to pi over 2. So this is 4 sine pi over 2x. Now, omega is equal to what? 2 pi f. So omega is 2 pi. Okay, so what is t? Time. Okay, so the time, the frequency, what is frequency? Frequency is 1 over t. 1 over t, right? So frequency is the time. Okay, so now let's see. The period is the time over second. So the time it takes 1 second, cycle 3. So period is 1 over 3. Okay, so you're gonna write period. So 2 pi over 1 over 3. So then 6 pi, right? Is that right? 6 pi. That's 6 pi. Okay, cosine 6 pi t. All right, so this is the equation, right? Now if you put the t, you get the graph. All right, so this is, now let's understand the other things. What other things you can understand? Harmonics. I promise you that I'm going to help you understand harmonics. So this is the, how many guitar I have? I have 1 guitar, okay? Because this is length L, this is length L, this is length L. How many guitar I have? I still have 1 guitar. So why? Because this is the first harmonic. First harmonic. So what is harmonic? Harmonic is to understand the harmonics. If I say ooh, you hear it. If I say you did not hear it, because the sound created in my mouth did not assault the air molecule, did not overcome the threshold. So air molecule really take the information from my mouth to your ear. Okay. So first harmonic is the minimum frequency you need to vibrate the string of the guitar. Great. Okay, so length. So this is the first harmonic. So this is, what is the wavelength of this one? Half lambda. Okay. 2 node, 1 anti-node. Okay. This is the wavelength. This is 1 wavelength, right? 2 loops. 2 loops, 3 anti-node. Second harmonic. All right. This is 3 over. This is 1.5 lambda. So 3 over 2 lambda. So this is third harmonic, right? So 3 loops, 4 nodes. Okay, so what is lambda then? Lambda is 2 pi, 2, let's see, I cannot think today. Lambda over 2 is, lambda is 2L. Okay, so lambda is 2L over 1. Lambda is 2L over 2. Lambda is 2L over 3. So then what is the lambda for nth harmonic? 2L over n. N is the loop, or they call it antinode. Okay, great. Now come back over here. You know velocity is lambda times frequency. So what do you mean? Lambda is velocity over frequency is velocity over lambda. So what is velocity? Oh, sorry. velocity is lambda is 2L, so 2LF. So what is F? F is uh, velocity over 2L. Okay, this is F1, the frequency, all right, fundamental frequency. This is very important because if I ask you what would be the frequency of nth harmonic, you're going to say n times F1, that's it. Integer multiple, okay, so n is 1, 2, 3, 4, n is always integer. So let's come over here. Velocity is lambda times frequency, all right. So what is lambda velocity over frequency? So lambda is, we found it 2L over n. 2L over n is velocity over frequency. Now we're gonna isolate f. So 2LF is Vn. So f is equal to 2L over, no, Vn over 2L, nv over 2L. V over 2L is F1. So and F1, right? So this is nth harmonic. All right, let's go over. It's very simple problem. Let's say I give you a string. A string is, I don't know, 1.2 meter long string, and the velocity is 120 meters per second, right? You're gonna find how many loops, all right? And they'll say third harmonics, right? So 1, 2, third harmonic. So 1, 2. And the lambda. So what is the lambda? Lambda is 2L over n. 2L over n. So 2 times 1.2 divided by 3. How much is this? 2 times 1.2 divided by 3 is 0.8. 0.8 meter. And what we're going to find? Velocity is lambda times frequency. So velocity is lambda 0.8 times frequency. Frequency is velocity is given. Frequency is, oh, let's find the frequency. All right, let's find the frequency. Frequency is 2V over 2L. So n is 3, 120, 2 times 1.2. So this is 60. So 180 divided by 1.2, and that is 150. Frequency is 150 hertz. All right, so this is pretty much it. Now, a standing wave has something called resonance. What is resonance? When you let something vibrate with natural frequency. Everything in the world, in the universe, vibrate with its natural frequency. Be it like a human, like me, or be it like a sun, moon, or building like this one, Brooklyn Cat, vibrate with natural frequency. Also, I don't know, Brooklyn Beach, I don't know, the wine glass, everything vibrate with natural frequency. Now, if you can somehow, right, accomplish the natural frequency of, let's say, a wine glass, then wine glass will vibrate, right, will vibrate. Its amplitude will go up, and wine glass at some point within 10 seconds shatter, broken pieces. For example, Tacoma breeze in 1940 at 11 a.m. A wind blow with 60 meters per second in Washington, right? And the amplitude, the initial amplitude was 0.3 meter per meter. And then the amplitude went up and up and up. By 12 p.m., the Tacoma breeze collapsed. Lots of people got killed, and that's an example of resonance, right? Because the wind 60 meters per second really accomplish the natural frequency of Tacoma breeze. Okay, and that's why amplitude went up. If it did not hit with the natural frequency, then it did not go up. So this is a Tacoma breeze, and the Tacoma breeze was 835 meters. I'm not making it up. You can check on the internet. So its primary amplitude is 0.3 meter. When it at 11 a.m. the wind blow 60 meter per second, and at 12 p.m. it collapsed. Right, and when it collapsed, it amplitude was 2.5. Right. Now we want to find the wavelength. Wavelength is 2L over N. Okay, so yes, it was the second harmonic. Second harmonic. Okay, so then second is 2 times 835 divided by 2. Second harmonic means 2 loops, so 835. What is 835 meters? That's lambda. So let's see the frequency of cycles it created. Well, it's actually influential, is actually the exponential growth. Uh, exponential growth. So what does that mean? That means AT is equal to EA ERT. All right. So amplitude, what was the initial amplitude at the time? 3600, right? So 3600. Okay. So initial amplitude is 2.5, initial amplitude 0.3, ERT is 3600, right? So you're gonna say that this is exponential growth. Okay, so all right, 3600 is equal to 2.5 divided by 0.3, right? So 2.5 divided by 0.3, 2.5 divided by 0.3 is 8. So 8. So ER3600 is equal to 8. So we're gonna multiply both sides by ln, right? So ln and E cancel. So R3600, right, is equal to ln 8. ln 8, which is 2. So R is 2 over 3600. 2 divided by 3600, and that is 5 times 10 raised to negative 4. 5 times 10 raised to negative 4. Okay, now if we come over here and then we do the math, 0.3 E, R is 5 times 10 raised to negative 4, and T is 3600, and that gives us 2.5 meter. So the final amplitude, initial amplitude was 2.3, and final amplitude was 2.5 meter, right? When the breeze collapsed, lots of people got killed, and that's called resonance. This is all I had to tell you about the waves, sound waves, right? Which is a form of mechanical wave that need medium to move, and medium is air, right? Oxygen, 21%, nitrogen 78%, and argon, which is 1%, right? Without it, you cannot. You can talk all day, but you cannot. Nobody is gonna be able to hear it. Good. Now, what are you gonna do? You're gonna take a popcorn, listen to this tutorial, and this is good for A85, and then this is also good for Einstein final and the Einstein competition 9 on Monday. I'll give you 2 more assignment, and that would be it. One assignment is going to be on nuclear physics, other assignment on Einstein photoelectric effect.